So that brings us to 6.4 on page 331. A lot of the material that we're going to cover today, you've kind of already seen since we went ahead and did 6.7. It worked out really well yesterday with class that we had already covered 6.7. That put people ahead of the game. The first couple things we talk about in 6.4 are the degree. What is the degree of a polynomial? That will be a homework question, and it'll be on the test. It will just have you tell me what the degree is. I guess kind of a definition for that is basically the highest exponent. The highest exponent that you see in the polynomial, that is the degree. Whatever it is, it doesn't matter the order. If you had x cubed plus 34x minus 16, what's the highest exponent you see there? And it's not the x, doesn't have anything to do, it's just the exponent. What's the highest exponent? Is 3. So if I wanted to know the 3 or the degree there, your answer is 3. Very simple. But again, it doesn't matter the order. If those were in the different order, something like that, what's the highest exponent you see? 3 still. So it's not necessarily the first one. Most of the time it will be. Most of the time we want them listed with the highest degree first, but that's not always the case, and it won't be on your homework. So it's whichever has the highest degree. Pretty simple. And the leading coefficient. Is the next thing you will have to know. The problems will ask you to name the degree and the leading coefficient. So you're going to have both of those things in each problem. And that is simply the coefficient that's with that highest degree term. The coefficient that's with the highest degree term. So looking back at those same examples, we said this was the highest degree term. What's the coefficient of that term? Do we know what's the coefficient? The coefficient's the number out front. In this case, it is a 1 right there. So the degree is 3, leading coefficient is 1. Same with this problem. We said this term had the highest degree. What's the coefficient? Again, positive 1. So for that problem, what's the highest degree? 4, so the degree is 4, and what is the coefficient of that term? -3. And that's how you'll list your answers, is 4 and -3. Those are the two things we're looking for. The other thing that we'll talk about on those same problems, it will ask you to state the degree and leading coefficient of each polynomial in one variable. And they will have some examples like that, and it will tell you state the degree and the leading coefficient. But they have to be polynomials in one variable. How many different variables do you see up there? Some would say 4, because you have 4 letters up there. But I'm talking about different letters. How many different letters do you see? 2. So that means they are not polynomials in one variable. So that's what you would write there. It's not a polynomial in one variable because you got 2 separate letters in the problem. Also, if you would see something like that, 1 over x, what is the degree of this variable right now? A 1. So if we were to bring that up to the top, it would be x squared plus, what would that become when we bring this up to the top? X to the -1. You can also not have negative exponents. So if you see a problem like this one, that is also not a polynomial. So if it's not, you just say that it's not. If it is, then you list the degree and the leading coefficient. don't forget those two cases. They are in your homework. If you look at the top of page 332, there's a couple more examples of that. The problem right there at the very top of the page is similar to this one. It says it's not a polynomial in one variable, it contains two variables. The next one's to check your progress 1A there. That is not a polynomial because you've got a variable in the bottom. So watch out for that. Questions on that? Next thing we're going to do, we did last time, is direct substitution. There is a couple very small differences. They say that f of x equals 2x squared plus 4, for instance. That's just a random polynomial, and they want you to find f of 2. What does that mean you do? Plug in 2 for all the x's. So we would have 2 times 2 squared plus 4. What would we do first? Multiply or square? Square. So we would have 4 here times 2 and 8 plus 4. So f of 2 equals 12. If you have a problem like that where it just wants you to find f of 2, do we have another method for that? We do synthetic substitution like we did last time. That's fine to use. If they just tell you to find f of 2, you can do it whichever method you want to today. I don't care at all which one you use. However, the slight difference I was talking about today, they will ask you to find f of 3a, maybe. So what does that mean that you're doing with 3a? You're plugging it in for all the x's, the same thing you did with the 2. So if you have a problem like this, you cannot do synthetic substitution. You'll have to use direct. But you still do the problem the same way. So what are we going to do first? Multiply or square? Square. And here's where rules from section 1 come into play. You got to square the 3 and the a. So that would give you, this right here would give you 9a squared times 2 would be 18a squared plus 4. And can you combine those? No, that's the end of your answer. So if you're plugging in other letters, you're probably not going to be able to get an answer like we got 12 here. It's probably going to end up something like that. Another thing they will do, they might have 5 times f of 2. So what are you going to have to find first there, you think? You have to find f of 2, and then what? Just take it times 5. Yesterday, I didn't cover this in class, and we hit this problem, and everyone totally freaked out. But it's really not that difficult. So you got to find f of 2, which we already did over there, right? What was f of 2? So you're going to do that again. You would find the 12 and simply take it times 5. What would you get there? So 60 would be your answer, if that were the case. So let's go ahead and look over at your homework problems if you want to. On page 335. Number 7 right there on page 335. Looks very similar to that. So that's all you're going to do there. What do you have to find first on number 7? Q of 2a. And they give you f and q in the directions. We sometimes, repeating q, I guess, we sometimes have difficulty reading those. They give you p function, which is 2x cubed plus 6x minus 12. And they give you the q function, which is 5x squared plus 4. So whichever one you got to know which one you're using there. Which one of those are you using on number 7? The q function, you put 2a in there, and then the final step would be what? Take it times 5, just like we did right up here. And one more scenario you'll run into they will ask you to find f of a plus 1, maybe. So what does that mean you're plugging in? A plus 1. Where do you plug in the a plus 1? For all the x's. So again, this is our f function. We're going to replace the x there with a plus 1. So 2 times a plus 1 squared plus 4. I've already covered this a couple times this year, but this problem right here is the most common mistake you will make in Algebra 2, Algebra 3, College Algebra, Trig, anything you take right here is the thing that is probably the most messed up. Because we're going to square this, right? And we're going to get what? A squared plus 1. And you're going to do that time and time and time again. You're going to square the a, and you're going to square the 1, and you're going to get a squared plus 1. And every time you do that, it could not be more incorrect. We get it confused, and the sooner you grasp this concept, the better off you'll be. You see that we had the squared here, and that we took that time, we simply squared both numbers, and we were done, and we moved on. What is the difference between this and this? You've got a plus in there. This is a binomial. This is not. It's fine to do everything squared there. Here, you cannot do that. What does the squared mean? It's times itself. So anytime you see this, you must come off to the side and write it twice and FOIL it. And you will have 3 terms when you get done doing it, not just the 2 that you got. Those 2 that you get when you do a squared plus 1, that is part of it, but you also will have a middle term. There is a shortcut that I may choose to teach later, but as of right now, I'm not going to, because I think that lends itself to causing you to make mistakes. So if we FOIL this, we're going to get a squared plus a plus 1. And we combine those 2 in the middle to give you 2 a's in the middle. So we have this 2, plugging in that we just did, a plus 2a plus 1 plus 4. And then what do we need to do? Distribute the 2 to everything. Now this is multiplying the 2 in. So we got 2a squared plus 4a plus 2 plus 4. Can we combine there? So we have 2a squared plus 4a plus 6. No like terms left. That's as simplified as it gets. There are, I think, 2 homework problems where you will have this scenario right here. Remember, you must FOIL it, not just square the first and last term. Bottom of page 333, I'm not going to write these up on the boards. You will have to actually look at your book if you want to see what we're covering next. We learned this last time a little bit, kind of pointed it out to you, but this is where we would have learned it if we didn't stick over this section in the first place. The constant function there, you have 6 graphs. We have a constant function, which is a horizontal line. How many times does that cross the x-axis? The x-axis. None. And what is the degree of it? 0. The next one is a linear function. The degree is 1. How many times does it cross? 1 time. The third one is a quadratic, which we've done 100 of. What's the degree? And how many times does it cross? But if you remember chapter 5, did a parabola have to cross twice? But what about the 2? How does that relate to the parabola? How many times does that one cross? How many times can a parabola cross? Maybe we should go that route. It can cross twice, once, or none. So what's the 2 represent? The what? The highest amount of times it can cross. It doesn't mean that if you have an x squared that it has to cross twice. It means that's the most that it would cross. So look down at the next row, the cubic function. What's its degree? How many times does that one cross? 3. Does it have to cross 3 times? No, it would not. We'll see that later. The same with the degree 4. That just means that 4 is the most it can cross, and the same with the quintic function. Has degree of 5. 5 is the most amount of times it could possibly cross. It doesn't have to cross 5 times. While we're looking at those graphs, another thing your homework will ask is how many real zeros. It will show you a graph, just like some of those on that page, and it will ask how many real zeros that it has. All that's asking is how many times does it cross the x-axis. Those are real zeros. It crosses. So how many real zeros does this one have? 4, and that's your answer. 1, 2, 3, and 4. So that has 4 real zeros. So a couple of the other graphs there. How many does that one have? 0. It will never cross the x-axis. So that has no real zeros. The last thing from the section is end behavior. End behavior. The notation that you have to write can be a little confusing, but as far as what you're talking about, it really shouldn't be that confusing. End behavior simply means what does the graph do as it goes to the left and right. That's basically what you're asking. What does the graph do as it goes to the left and the right? Does it go up or does it point down? And I'll show you what we mean by that, but that's basically what you're trying to figure out. Does your graph go up or down? So we have this graph, and these will all be graphed. You're just going to look at a graph and tell me whether it's going up or down. So might be like that. So that's your graph. Tell me, is it going up or down as I go to the left and the right? So here's the question. As we move along this x-axis, we are going to the right. As we are going along to the right, which way is the graph being this curvy line here? So as we move along here, which way is the graph pointing? Is it pointing up or is it pointing down? It is pointing up. So as we go to the right, we just said the graph goes what? Graph goes up. So then as we are moving to the left, going this way, which way is the graph pointing, up or down? It is now pointing down. So you could also write that. So as we move to the left, the graph points or goes down. That's pretty simple normal English that you're used to using. Only that's not what we use in math. So we have to turn those phrases into the correct notation. So as we go to the right, what's the graph doing? Going up. So another word for the graph is f of x. That's the function. F of x goes to, that's what the arrow means, f of x goes to positive infinity, which is a sideways 8. going up. We said that. That's the other word for up, is positive infinity. So f of x goes up as we move where? To the right. And the way we write that is as x goes to positive infinity. So f of x goes up as x goes to positive infinity, because that's heading to bigger and bigger numbers. So for the left side, we say f of x goes to, where was it going when we went to the left? I mean, where did we write that it was going? Down. So the other word for down is negative infinity. It's approaching smaller and smaller numbers forever. It's going down. As x goes to, where's x going as we head to the left forever? Negative infinity as well. So you'll answer that for every single time it asks for end behavior. You'll look at it going both directions. So which one of these will not change, your x's or your functions? Which one will always be the same for every problem? The x's. This part right here will never change, because this just means as x goes to the right, and this means as x goes to the left. So those two parts will never change, and neither will any of this. What's the only part that's going to possibly change? And the sign in front of the infinities. So the only thing that will ever be any different is this right here, whether it's going up or whether it's going down. Everything else will stay exactly the same. How many real zeros do we have there? 3, and that'll be the other question you'll answer. So let's do one more of those, start to finish. And forgot one other thing. How many real zeros does that one have? 2, crosses twice. And remember, we can write f of x goes to what? I guess that would be a blank you could fill in. As x goes to the right. And f of x goes to what? As x goes to the left. Yes, so this will all be written every single time, and this is the only thing that will change, whether it's positive or negative. So as x goes to the right, which way is the graph pointing? Down, so that would be negative infinity. And as x goes back to the left, where's the graph pointing? Down, so that would also be negative infinity. We already said how many real zeros? And one other thing I forgot to mention was odd or even, and it's very simple. Let's look at the graphs top of 334. And we'll apply that to this problem. Yeah. So we have a graph, 4 graphs there in the middle of page 334 at the top half. Looking at the first one, that is a parabola. Which way does the graph point on that one? Both of them point up. And what's the degree say? Even. Look at the next one over. Which way do they both point? One up and one down. What's the degree say? Odd. So look at the third one. Which way do they point? Both down, and it's, and the last one of each is one of each up and down, so it is odd. So what would this be? Even. So if they both arrows point the same direction, they can both be up or both be down. But if they point the same direction, it is even. So the example we did previously, this one would be odd. And it will ask you each one of those things. You'll have to do in behavior, how many real zeros, And is it odd or even? Homework 1 through 33. On page 335 and 336.